On October 19, 2025, a single calculation, published not in a grand press conference, but in a quiet, almost unassuming paper by Harvard astrophysicist Avi Loeb, sent tremors through the foundations of the scientific world. It was a calculation that didn't just challenge our understanding, it threatened to shatter it. The interstellar object we had been tracking with a mixture of excitement and detached curiosity, the object designated 3I/Atlas, was not what we had been led to believe. The estimates of its mass, a fundamental property we thought we had constrained, were revised. Not by a small margin of error, not by 10 or 20%, but by an order of magnitude that bordered on the absurd. The new number was 33 billion tons. To truly wrap your mind around that figure, you have to let go of conventional scales. This is not the mass of a building or a ship. This is geological mass. Imagine a solid, perfect cube of ice, 5 kilometers tall, 5 kilometers wide, and 5 kilometers deep. A frozen mountain pulled from the cosmos. Now, imagine that colossal mass compressed into an object hurtling through the silent vacuum of our solar system at a velocity that defies easy comprehension. 58 kilometers per second. That's fast enough to treat the sun's immense gravitational pull as a minor inconvenience, a cosmic speed bump on an otherwise unimpeded journey. It is a visitor, not a resident. It is old, ancient beyond our ability to truly conceive, potentially having formed in the swirling dust and gas of a stellar nursery that died out long before our own sun flickered into existence. And yet, the unified chorus from every space agency with eyes on the sky, from NASA to the ESA, has been a soothing, almost hypnotic mantra. It poses absolutely no threat to Earth. But that is what they are telling us. The truly unsettling part, the part that keeps a certain kind of mind awake in the dead of night, is what they aren't telling us. Or perhaps, what they themselves cannot yet articulate. Because sometimes, the most profound and important questions aren't the ones you can plug into a risk assessment algorithm. They aren't about impact probabilities or calculating orbital mechanics to the 10th decimal place. Sometimes, the questions that truly matter are simpler, stranger, and far more disturbing. What is it really? Where did it come from? And what, in the name of all that is known, is it doing out there, so close to Mars? If you feel that same chill of profound curiosity, that sense that we are standing on the precipice of a revelation that could change everything, then I urge you to consider subscribing. This story is not a historical account. It is unfolding in real time, right now, as you watch this. And the implications stretch far beyond the dry world of astronomy. They touch upon the very definition of who we are and what our place is in this universe. Before we go any further, tell me in the comments where you are watching from, what time it is in your part of the world, and answer me this. Do you believe we are being told the whole story? Our journey into this mystery doesn't begin in the hallowed, ivy-covered halls of Harvard. It begins on July 1st, 2025, in the high, thin, achingly clear air of the Chilean Atacama Desert. Here, the Atlas Survey Telescope, the asteroid terrestrial impact last alert system, carries out its nightly vigil. It is a system designed with a singular, pragmatic purpose: to scan the heavens for potentially hazardous asteroids, the city killers and planet scarers that haunt our cosmic neighborhood. On that night, an automated algorithm flagged something unusual. The alert that chimed in a quiet control room wasn't triggered because the object was terrifyingly large, nor because it was dangerously close. It was flagged because its movement defied the celestial rules. The preliminary orbital calculations, run and rerun by the system in a cascade of verifications, suggested something that simply should not be possible. It was moving too fast. The object, initially given the sterile, almost bureaucratic designation A11/PL3Z before receiving its formal name, 3I/Atlas, was traveling at a velocity that placed it firmly, unequivocally, outside the sun's gravitational binding. This was not a familiar threat. This was not an asteroid knocked loose from the vast, chaotic belt that tumbles between Mars and Jupiter. This was not a long-period comet, a dirty snowball falling in from the cold, dark abyss of the Oort cloud at the farthest edge of our solar system. This was something else entirely. It was an outsider, a traveler from interstellar space, an emissary from another star. Within 48 hours, the initial, startling findings were confirmed. A flurry of alerts went out across the global network of astronomers. Telescopes around the world, from Hawaii to the Canary Islands, swiveled to lock onto the coordinates. The data poured in, and it all said the same thing. Astronomers, in a frantic search for context, began digging through archived sky survey data. They found it. Pre-discovery images, faint traces of the object captured as far back as mid-June, lurking unnoticed in the background noise of older observations. It had been in our cosmic backyard for weeks, a silent ghost slipping past our centuries. The single most critical data point, the number that separated it from everything else we had ever seen, was its orbital eccentricity. Eccentricity is a simple measure of how stretched an orbit is. A perfect circle has an eccentricity of 0. Earth's orbit, a nearly perfect circle, is 0.017. Mars, with a slightly more elongated path, is 0.093. Even the most extreme, long-period comets in our solar system, those that swing in from the depths of space on journeys lasting thousands of years, rarely have an eccentricity that exceeds 1. An eccentricity greater than 1 is the cosmic line in the sand. It signifies an open, hyperbolic orbit. It means the object is not bound to our sun. It is on a one-way trip, a fleeting visitor just passing through. 3I/Atlas has an orbital eccentricity of 6.14. Let that number sink in. This isn't just another data point. It is a statement. It places this object in a category all its own, on one of the most extreme, high-energy trajectories ever recorded. It is more extreme than Oumuamua, the enigmatic, cigar-shaped object that baffled scientists during its brief visit in 2017, which had an already shocking eccentricity of 1.2. It is more extreme than 2I/Borisov, the first object we confirmed as an active interstellar comet, which arrived in 2019 with an eccentricity of 3.4. 3I/Atlas is moving as if it were violently ejected, thrown with incredible force from its home star system. It is a cosmic projectile that has been traveling through the cold, lonely darkness between the stars for millions, perhaps even billions, of years. And here, in the cold, hard math of its trajectory, the story takes its first truly strange and unsettling turn. Interstellar objects, the debris cast off from distant star systems, should, by all rights, arrive from random directions. Space is a three-dimensional arena. There is no inherent up or down, no cosmic highway, no preferential path of entry. If you were to create a celestial map and plot the arrival vectors of countless comets and asteroids ejected from other star systems through natural processes like planetary collisions or the death throes of a star, they should be scattered as evenly as raindrops on a pavement. There should be no pattern. Yet, 3I/Atlas arrived at an orbital inclination of just 4.89 degrees relative to Earth's orbital plane, the ecliptic. The ecliptic is the flat, disk-like plane where all the planets in our solar system orbit the Sun. This object entered our home almost perfectly aligned with that plane. It threaded the needle. The probability of this happening by sheer, random chance is vanishingly small. Avi Loeb, in his publications and interviews, has calculated the odds at approximately 1 in 500. He has been relentless in emphasizing this point, his voice a consistent note of intellectual alarm in a chorus of cautious dismissal. The trajectory is not just unusual. It is a profound statistical anomaly. It is a cosmic coincidence of the highest order. Of course, some of his colleagues in the astronomical community have pushed back. Science is a conversation, often a contentious one. They suggest that the probability might be slightly higher when you factor in certain observational biases. Perhaps our telescopes, which are themselves situated on the ecliptic plane, are more likely to spot objects that travel along that same plane. It's a selection effect, they argue. Maybe the true odds are closer to 1 in 50, or even 1 in 20. But even if we accept these more conservative estimates, you are still looking at an event of profound rarity, something that cries out for an explanation beyond, it just happened that way. When you begin to layer this trajectory anomaly on top of the other bizarre properties of 3I/Atlas, its composition, its behavior, its sheer, unprecedented mass, that explanation becomes increasingly elusive, and the implications become increasingly unsettling. On August 7, 2025, the narrative took a visual turn. NASA released the first high-resolution images of the object, captured by the venerable Hubble Space Telescope. The pictures, eagerly awaited by the public and scientists alike, showed a diffuse, ethereal, teardrop-shaped glow, a classic cometary coma of gas and dust surrounding a solid, unresolved nucleus. It looked, for all intents and purposes, like a textbook comet. A sigh of collective relief seemed to ripple through the mainstream astronomical community. But beneath that familiar, fuzzy appearance, a deep and troubling problem was lurking. Comets are supposed to be relatively small. Most of the comets native to our solar system, the ones we've studied for centuries, have nuclei ranging from a few hundred meters to perhaps 10 kilometers across. They are, essentially, dirty snowballs. The largest one we know of, the behemoth known as Comet Bernard-Nelly-Bernstein, has a nucleus estimated at a staggering 150 kilometers in diameter, and it was considered an exceptionally rare, 1 in a million giant. Based on the brightness of 3I/Atlas and the standard assumptions astronomers make about its reflectivity, or albedo, the early estimates placed its diameter somewhere between 5 and 20 kilometers. Larger than average, certainly, but not impossibly so. It fit within the known parameters, albeit at the extreme upper end. Then, the precision mass calculations began to trickle in from observatories that had been tracking the object's motion with painstaking accuracy. And by late September, astronomers noticed that something crucial was missing, something that should have been there. 3I/Atlas showed no detectable non-gravitational acceleration. This is a subtle but profoundly important point. When a comet gets close to the sun, the intense solar radiation heats its surface. Volatile ices like water, carbon dioxide, and carbon monoxide don't melt. They sublimate, turning directly from a solid into a gas. This escaping gas, carrying fine particles of dust with it, erupts from the nucleus in jets and plumes, forming the beautiful coma and tail we associate with comets. But this process is rarely, if ever, perfectly symmetrical. The jets of gas act like tiny, unpredictable rocket engines, pushing the comet around and subtly altering its trajectory in ways that cannot be explained by the pure, clean force of gravity alone. 2I/Borisov, the previous interstellar comet we had studied, exhibited this non-gravitational acceleration clearly. It's normal. It's expected behavior. But 3I/Atlas, despite having a prominent and active coma, showed none. This stark observation implies one of two things, and both are deeply problematic. The first possibility is that the object isn't actually outgassing in the way we think, but that directly contradicts the clear visual evidence of the coma surrounding it. The second possibility is that the object is so incredibly, unbelievably massive that the thrust from all that escaping gas is negligible compared to its immense inertia. It's like trying to change the course of an aircraft carrier by blowing on its sail. Avi Loeb, a physicist at his core, did the math. He calculated the staggering implications. If 3I/Atlas is producing a visible coma of that size and brightness without any measurable thrust affecting its path, it must be far, far more massive than its size would suggest. This is what led directly to the revised, headline-grabbing estimate: over 33 billion tons. Take a moment to let that number truly land. A typical comet is a porous, fragile body of ice and dust, with a density often lower than that of water. If you were to compress 33 billion tons of material into a sphere just 5 kilometers across, you would require an average density of roughly 1,300 kilograms per cubic meter. That is denser than water ice. It is denser than the composition of most known comets. It is a density that is more consistent with solid rock, or even metal, or something else entirely, something more compact, more engineered. This is not how comets are supposed to behave. This is not what naturally occurring interstellar debris should look like. And yet, every official statement from every space agency has been a monotonous repetition of the same line. No threat, natural object, routine observation. But if this object is as massive as the calculations indicate, and if it is maintaining its trajectory with such unnerving, machine-like precision despite actively shedding material into space, then we are looking at something that fundamentally breaks all of our models. We are looking at an anomaly of the highest and most profound order. The mystery deepened, becoming more specific and more chemical in nature, on August 21st, 2025. On that night, the Very Large Telescope, a marvel of engineering perched high in the Chilean desert, focused its powerful instruments on the faint smudge of light that was 3I/Atlas. Its goal was to perform a spectroscopic analysis, to break down the light from the object's coma into its constituent wavelengths, revealing the chemical fingerprints of the materials being released. The initial findings were, once again, deceptively familiar. The spectral lines for carbon dioxide, water vapor, carbon monoxide, and even cyanide were all present. These are all expected components of cometary chemistry, the building blocks of life and the cosmos. But hidden within the complex squiggles of the data, there was something else. Something that gave the astronomers on duty pause, something that made them check their instruments and rerun their calibrations. Nickel. Atomic nickel vapor was detected in the coma, in concentrations that were surprisingly similar to those seen in comets from our own solar system. While this was unusual, it wasn't entirely unprecedented. Nickel emission has been observed in a handful of comets before. The current theory is that it can be explained by the sublimation of exotic nickel-containing compounds that are embedded like flecks of metal within the comet's icy matrix. The truly unprecedented part, the detail that turned a scientific curiosity into a profound enigma, was what was missing: iron. In every single comet ever documented where nickel has been detected, iron has appeared right alongside it. In the crucible of stellar nucleosynthesis, in the fiery hearts of dying stars where heavy elements are forged, nickel and iron are created as chemical twins. They are bound by the laws of physics. They travel together through the cosmos, locked in the same mineral structures. And they should appear in roughly equal proportions when a comet outgasses and releases its contents into space. 3I/Atlas is emitting significant, measurable quantities of nickel with no detectable trace of iron. This single observation violates our most basic and fundamental expectations of cosmic chemistry. Finding abundant nickel with virtually no iron is like finding smoke without a fire, a footprint without a foot. It points to one of two possibilities. The first is an extraordinarily strange and unique formation environment, a corner of a distant star system where some unknown process had managed to deplete all the iron while leaving the nickel behind, a fractionation process we have never observed in nature and cannot easily explain. The second interpretation, the one that makes the conversation deeply uncomfortable for mainstream scientists, is that this isn't chemistry we don't understand. Avi Loeb, never one to shy away from the unsettling implications, has pointed out that nickel-iron alloys are ubiquitous in human industrial manufacturing, particularly in high-performance, aerospace-grade materials and superalloys designed to withstand extreme temperatures and mechanical stresses. There are two ways to look at this chemical signature. The conservative, safe interpretation is that we are witnessing a rare, but perfectly natural chemical process that we just don't understand yet. The other interpretation, the one that is whispered in private conversations after the official press conferences have ended, the one that circulates on leaked forum posts and in encrypted chats, is that this isn't chemistry we don't understand. It's chemistry we understand all too well, just not from a natural source. The climax of the initial observation campaign, the moment of greatest anticipation, was set for October 3rd, 2025. On that day, 3I/Atlas was scheduled to make its closest approach to any planet during its entire journey through our solar system, passing within a mere 29 million kilometers of Mars. An unprecedented international armada of 7 spacecraft from 4 different national and international space agencies was in position, ready to observe. The European Space Agency's ExoMars Trace Gas Orbiter and its venerable Mars Express Orbiter, NASA's Mars Reconnaissance Orbiter, armed with its HiRISE camera, the most powerful and high-resolution camera ever sent to another planet, the United Arab Emirates Hope Orbiter, and China's Tianwen-1 mission. This was our golden opportunity. This was the best, and likely the last, chance anyone would ever have to image 3I/Atlas at a resolution that could reveal its true nature. The hype in the astronomical community and among the interested public was palpable. Scientists promised clarity. They promised answers. They promised, perhaps, definitive proof of what this enigmatic object truly was. Then, the images began to arrive, and the story took another sharp, frustrating turn. On October 7th and 8th, the European Space Agency was the first to release its findings. The pictures from the ExoMars Trace Gas Orbiter were underwhelming. They showed a fuzzy, indistinct, overexposed white moving slowly against a static backdrop of stars. There was no detail, no structure, no hint of a solid nucleus. Nothing that could help us understand whether we were looking at a pristine, primordial remnant from another star system or something far, far stranger. The backlash online was immediate and fierce. The global community of amateur astrophotographers, a talented and often overlooked group, erupted in frustration. They began posting their own images of distant comets, images captured with backyard telescopes that were demonstrably sharper and more detailed than what the multi-billion-dollar European space probe had produced. The ESA's official response was technical, bureaucratic, and measured. Their cameras, they explained, were designed and optimized to photograph the bright, sunlit surface of Mars from close range, not faint, dim objects tens of millions of kilometers away in the blackness of space. The object was, they claimed, thousands of times dimmer than their usual photographic targets. They released what they had, and that was that. But this careful, technical explanation didn't quite add up. It didn't account for NASA's Mars Reconnaissance Orbiter and specifically, its crown jewel instrument, the HiRISE camera. HiRISE's resolution is nothing short of extraordinary. From its orbit high above Mars, it can distinguish features on the planet's surface the size of a dining room table. At the distance of 3I/Atlas during its closest approach, HiRISE should have been able to achieve a resolution of approximately 30 meters per pixel. That is 10 times better, 10 times more detailed than what the ESA cameras had managed. If there were any geometric features, any sharp edges, any structure at all that contradicted the natural comet hypothesis, HiRISE would have seen it. Those images have never been released to the public. The official explanation that came from NASA was both mundane and, in its timing, utterly surreal. The United States government had shut down. Due to a budgetary impasse in Congress, over 15,000 NASA employees, representing more than 80% of the agency's dedicated workforce, had been furloughed. The NASA website wasn't being updated. Public communications and press releases had ceased entirely. It was a case of complete bureaucratic paralysis at the worst, most scientifically critical moment imaginable. But this excuse, convenient as it was, began to look thin under scrutiny. The ESA, a European agency completely unaffected by American political dysfunction, had managed to release their blurry images. China's Tianwen, one orbiter, which was also perfectly positioned to observe, remained completely silent. The UAE's Hope orbiter, which had a clear, unobstructed view, also shared nothing. Multiple, independent space agencies, representing multiple sovereign governments with their own separate bureaucracies, priorities, and political interests, were all simultaneously unable or unwilling to release their best data on what was inarguably the most scientifically significant object to visit our solar system in years. The timing, the synchronicity of the silence, was difficult to ignore. It began to feel less like a coincidence and more like a coordinated response. While the world's most powerful space agencies remained silent, the global community of amateur astronomers, citizen scientists, and passionate skywatchers took matters into their own hands. On October 3rd, the very same day as the Mars flyby, a Portuguese amateur astronomer known to the online community by the username Dobsonian Power uploaded an image to social media that would ignite a firestorm of controversy. Using a powerful solar telescope, a piece of equipment not at all designed for faint, deep space objects, and applying aggressive, experimental digital enhancement techniques, he had captured what appeared to be distinct, angular structures nestled within the diffuse, glowing coma of 3I/Atlas. The image showed dark, geometric shapes, sharp protrusions that did not match the typical, soft, ethereal glow of a natural comet. His caption was simple, a reflection of his own astonishment. "What on earth is it?" Within hours, the image went viral. Astronomy forums and social media platforms exploded with frantic debate, instantly polarizing into two entrenched camps. One group, energized and vindicated, saw this as the smoking gun, irrefutable proof of artificial structures, clear evidence that 3I/Atlas was not what mainstream science was claiming. The other group, composed largely of professional astronomers and skeptical debunkers, dismissed it as a classic case of pareidolia, the human brain's tendency to perceive meaningful patterns in random noise. The effect, they argued, was amplified by the use of completely inappropriate equipment. Solar telescopes use highly specialized filters designed to handle the sun's extreme brightness, and the aggressive digital processing required to pull a faint object out of the noise had likely created a cascade of visual artifacts, inventing details that weren't really there. What made the situation so complicated and fascinating was the identity of Dobsonian Power himself. He wasn't a known conspiracy theorist or a peddler of UFO hoaxes. He was a widely respected amateur astronomer with over a decade of meticulously documented astrophotography work. His equipment was legitimate. His methods, while unorthodox for this target, were transparently explained. And when pressed by a deluge of questions and accusations, he didn't double down with wild, sensationalist claims. He acknowledged the deep uncertainty. He conceded that the structures could be artifacts. He promised to try again, with different equipment, when the object became more visible from Earth in early November. His response was measured, scientific, and appropriately cautious. And that made the reaction from certain quarters even more telling. Within 24 hours of his post going viral, multiple science news websites and blogs published articles specifically and aggressively debunking his image. The timing felt coordinated. The tone felt unusually defensive, almost panicked, as if there was an urgent, unspoken need to establish an official narrative, that nothing unusual was photographed, before the amateur's image could gain too much traction and solidify in the public consciousness. This official debunking campaign had the opposite of its intended effect. It sparked what became known as the enhancement wars. Inspired and emboldened, users across Reddit, Twitter, and various image processing forums began downloading the original, blurry, official ESA images and running them through their own enhancement algorithms. Some used standard astronomical stacking techniques, combining multiple frames to reduce noise. Others employed sophisticated, cutting-edge AI upscaling tools, neural networks designed for enhancing low-resolution photos. The results were a chaotic, bewildering, and utterly contradictory mess. Some of the enhanced images showed nothing more than slightly sharper versions of the same fuzzy, featureless data. But others, many others, revealed what appeared to be distinct, tantalizing geometric patterns. They showed sharp edges, flat surfaces, and structures that seemed far too regular to be the random, chaotic agglomeration of natural ice and rock. The fundamental problem, of course, is that once you begin to aggressively process a digital image, especially with powerful AI tools, you are no longer simply looking at what's actually there. You are, in a very real sense, looking at what an algorithm thinks should be there, based on the vast library of images it was trained on. It is a scientific dead end wrapped in the seductive illusion of clarity. But the uncontrolled proliferation of these thousands of enhanced images had a profound and perhaps deliberate unintended effect. It muddied the waters so thoroughly, so completely, that distinguishing between a potentially legitimate observation and an obvious fabrication became nearly impossible. Within 48 hours of the initial ESA photo release, dozens upon dozens of supposedly enhanced versions were circulating online. Some showed impossibly detailed metallic surfaces. Others depicted what looked like vast solar panels or intricate antenna arrays. Most were obviously, laughably fake, the products of overzealous imaginations. But mixed in with this overwhelming flood of digital noise were a handful of images that felt different. They were more subtle, less sensational. They were images that showed just enough unusual regularity, just enough of a hint of non-random structure, to make you wonder whether something real, something truly anomalous, was being deliberately obscured by a tidal wave of obvious hoaxes. It was a perfect storm of disinformation, making it impossible to see the truth. Let's step back from the blurry images and the online debates and return to the cold, hard, unforgiving reality of the math. Let's talk about probability. Imagine you are standing on a rapidly spinning Earth, blindfolded, and you throw a single dart at a globe positioned on the other side of a large room. Now, imagine that your single, randomly thrown dart not only hits the globe but lands within a few degrees of its equator. That is the level of statistical improbability we are grappling with when we examine the precise trajectory of 3I/Atlas. As we've established, it arrived with an orbital inclination of less than 5 degrees relative to our solar system's ecliptic plane. This narrow corridor represents less than 1% of all possible arrival angles. For comparison, let's look at the other interstellar visitors we've detected. Oumuamua, the first, arrived at a wildly tilted inclination of 123 degrees, plunging down from above the solar system plane. 2I/Borisov, the second, came in at a steep 44 degrees. Both of these trajectories are exactly what you would expect for natural objects randomly ejected from distant star systems. They are consistent with a chaotic, random origin. 3I/Atlas is the outlier. It is the anomaly. It is the one that doesn't fit the established pattern. Now, before anyone suggests that perhaps there's a natural reason for this, consider this crucial detail. The galactic disk itself, the vast, flat structure of the Milky Way where most stars reside, is tilted at an angle of about 60 degrees relative to our solar system's ecliptic plane. So, if 3I/Atlas came from a typical star system within the galactic disk and was ejected through some random, natural process, basic geometry and physics predict that it should have arrived at a steep angle, not a shallow one. The alignment we observe is, in fact, the opposite of what a natural origin within our galaxy would suggest. So let's stack the anomalies, one on top of the other, like a precarious, teetering tower of improbabilities. First, an unusual and unprecedented mass of 33 billion tons, far larger and denser than any typical comet. Second, a bizarre and physically contradictory chemical signature, significant nickel emission with no detectable iron. Third, A trajectory of such unnerving precision, a 1 in 100 alignment with our planetary plane that defies statistical likelihood. And then, layered on top of all of that, the missing high-resolution images from multiple, independent international space agencies, coupled with a perfectly timed government shutdown that provided the ideal excuse for the most critical data to be withheld. Any single one of these anomalies, taken in isolation, could be plausibly explained away. It could be a coincidence. It could be a measurement error. It could be a case of simple bureaucratic incompetence. But when you start stacking these anomalies together, when you multiply these small probabilities by one another, the compound improbability becomes staggering. The natural object explanation begins to feel less like the simplest answer, less like Occam's razor, and more like a desperate, willful act of rationalization in the face of overwhelming strangeness. The story grows stranger still, acquiring a new layer of temporal mystery when you look back not just a few months, but decades into the past. On the night of August 15th, 1977, at the Big Ear Radio Telescope in Ohio, a graduate student named Jerry Emmon was reviewing the data printouts from the previous night's observations. Suddenly, he saw it. A 72-second-long burst of radio energy, so powerful, so distinct, and so perfectly structured that in a moment of pure, unadulterated scientific astonishment, he circled the alphanumeric code for the signal, 6EQUJ5, and wrote a single, now famous word in the margin of the printout. Wow. For nearly 5 decades, the wow signal has remained one of the greatest and most enduring mysteries in the entire search for extraterrestrial intelligence, SETI. It came from the direction of the constellation Sagittarius. It was a narrowband signal, focused at a very specific frequency, and it has never, ever repeated. Thousands of hours of follow-up observations have been dedicated to that same patch of sky. The result has always been the same. Nothing. Just that one, tantalizing, 72-second burst, and then eternal silence. Until Avi Loeb, driven by the cascade of anomalies surrounding 3I/Atlas, decided to run the numbers. He performed a simple but brilliant calculation. He wound back the clock, using the precisely determined trajectory of 3I/Atlas to calculate its position in the sky on August 12, 1977, 3 days before the WOW signal was detected. On that date, the object was approximately 600 astronomical units from Earth, 600 times the distance between the Earth and the Sun, deep in the outer darkness of our solar system. More importantly, he calculated the direction it was coming from at that time. He then compared that position to the origin point of the WOW signal. The two directions, the source of the 1977 radio burst and the origin path of the 2025 object, are separated by a mere 9 degrees in the vast, empty expanse of the sky. The probability of this close directional alignment between two completely independent, anomalous events happening by sheer chance is about 0.6%. Not impossible, but deeply, deeply suspicious. Loeb, ever the physicist, took the hypothesis one step further. If 3I/Atlas had, in fact, been the source of the WOW signal, how powerful would its transmitter have needed to be? The math is straightforward. The signal's intensity, as detected by the Big Ear telescope, corresponds to a transmitter output between 0.5 and 2 gigawatts. For reference, a typical nuclear power reactor on Earth produces about 1 gigawatt of power. So, we are talking about the energy level of a modern nuclear power plant, focused into a narrow, directed radio beam. This is not an impossible amount of energy for an advanced technological civilization. In fact, it's a very reasonable and efficient amount of power if your goal is to send a detectable ping or reconnaissance pulse across the vast distances of interstellar space without wasting enormous amounts of energy on an omnidirectional broadcast. There's another compelling detail that makes this connection harder to dismiss. The WOW signal was observed at a frequency that was slightly blue-shifted, indicating that its source was moving rapidly toward us. This is perfectly consistent with the trajectory of 3I/Atlas. It would be trivially easy to check this connection, to either confirm or completely debunk it. All we would have to do is point our most powerful radio telescopes, like the Green Bank Telescope or the recently completed Square Kilometer Array, at 3I/Atlas and listen. Listen intently at the hydrogen line frequency where the WOW signal was found. If it is transmitting, if it is still active, we would know within hours. It is a simple test with a potentially definitive, world-changing answer. And yet, as Loeb has repeatedly and frustratingly noted in his blog posts and public statements, the global radio astronomy community has been deafeningly silent. No major radio observatory has publicly reported any data on 3I/Atlas. The SETI Institute, the very organization whose entire purpose is to search for such signals, has not announced any dedicated monitoring efforts. The silence from the people with the instruments to listen is, in its own way, as loud and as unnerving as the WOW signal itself. In less than 72 hours from the time of this recording, on October 29, 2025, 3I/Atlas will reach perihelion. That is the point in its orbit where it makes its closest approach to the Sun. For any natural comet, this is the moment of truth. The intense, brutal solar radiation at that distance should cause dramatic, explosive outgassing. It might even cause the object to fragment and break apart. We have seen it happen before. Comets that fly too close to the Sun are torn apart by the heat and gravitational forces. If 3I/Atlas is just an ordinary, albeit very large, chunk of ice and rock from another star system, that is exactly what should occur. But here is the problem, the supreme, frustrating irony of the situation. We won't be able to see it happen. During this entire critical period, during its moment of maximum stress and activity, the object will be on the opposite side of the Sun from Earth. It will be completely lost in the brilliant, blinding solar glare. Every single ground-based and near-Earth telescope on our planet will be rendered useless. Some have called it a case of deeply unfortunate timing. Others, a growing number of them, see it as suspiciously, almost intelligently, convenient. In a blog post published on October 3rd, the very day of the Mars flyby, Avi Loeb laid out the two starkly different scenarios for this perihelion passage. If 3I/Atlas is a natural comet, he wrote, it may erupt in a spectacular flare of outgassing or break up into a cloud of icy fragments. The Sun will be depositing gigawatts of power onto its surface. That energy has to go somewhere. For natural ice and rock, it goes into vaporization, sublimation, and potentially catastrophic structural failure. But then, Loeb added the alternative, the hypothesis he has been carefully building towards. If it is technological, he wrote, it may maneuver to benefit from the Sun's gravitational assist, or, in a phrase that sends a chill down the spine, release probes that could intercept Earth or other planets. Read that again. Release probes that could intercept Earth. He is no longer talking about passive observation or abstract scientific principles. He is talking about active deployment. He is talking about a potential action taken against our planet. And in his analysis, the object's retrograde orbit, its movement opposite to the direction of our planets, is key. Any probe it releases doesn't have to fight against planetary motion to reach us. It can simply be dropped into a carefully calculated intercept trajectory and let the simple, elegant math of orbital mechanics do the rest of the work. From its hidden position behind the Sun, concealed from our view, it would be a trivial matter to launch something small, dark, and fast toward Earth that we would not be able to detect until it was already far too close. In that same analysis, Loeb made a statement that took the discussion out of the realm of abstract science and into the cold, hard world of geopolitics and finance. He wrote, when you look at the Sun in the coming weeks, keep in mind that 3I/Atlas is passing behind it. If 3I/Atlas maneuvers toward Earth when it reappears on the other side of the Sun, the financial markets may crash. That is not a metaphor. That is not hyperbole. He is suggesting, with the full weight of his academic authority, that if this object demonstrates undeniable technological capability, if it actively and deliberately alters its course toward our planet after its perihelion passage, the economic and social consequences would be immediate, catastrophic, and severe. Global stock markets thrive on predictability and respond to uncertainty with fear. The existential level uncertainty of a potentially hostile interstellar object actively changing its trajectory to approach our planet would shatter the global economy in a matter of hours. While the world's major observatories are blinded by the sun, one small, independent group is still watching. Or rather, they are waiting. The Galileo Project, the research initiative founded and led by Avi Loeb himself, operates a network of small, specialized observatories. Their primary mission is not to study known objects, but to systematically scan the skies for anomalous phenomena, for objects that do not behave according to known physics. Their logic, in this specific case, is simple and direct. If 3I/Atlas does, in fact, deploy probes during its passage behind the sun, those smaller, darker, and faster-moving objects would have to travel from their launch point toward Earth. They would cross our skies, and they might, just might, be detectable by the Galileo Project's sensitive, high-speed cameras and instruments. It is a long shot of astronomical proportions. Their handful of observatories covers only a tiny, minuscule fraction of the sky, but it is more than anyone else is officially doing. They are applying rigorous, unbiased scientific methodology to a question that has been relegated to the fringes, to the realm of science fiction and conspiracy, for far too long. Are there technological artifacts of non-human origin in Earth's vicinity that we have been systematically missing, simply because we weren't looking in the right way, with the right tools, and with an open mind? In the second week of November, 3I/Atlas will emerge from behind the sun. It will once again become visible to our telescopes. We will be able to track its movement again. We will measure its brightness. We will analyze its chemical spectrum, and most importantly, we will calculate its new trajectory with exquisite precision. And then, we will know if anything has changed. If it emerges on the same predictable path, perhaps showing signs of natural fragmentation or increased cometary activity, the mystery will be largely, if not entirely, solved. It will go down in the history books as a very unusual, but ultimately natural, interstellar visitor. A fascinating footnote in the story of astronomy. But if it doesn't, if its trajectory has been altered in a way that cannot be explained by natural forces, if it has maneuvered, then we, as a species, will find ourselves in completely uncharted territory. We will be facing a new reality. This forces us, it compels us, to finally confront the hypothesis that almost no one in a position of authority wants to articulate publicly. Not because it is scientifically impossible, but because the very act of saying it out loud changes the conversation in ways that are profound and difficult to walk back. What if 3I/Atlas isn't natural? Not in the simplistic sense of being a crude spacecraft, something with windows and occupants and deliberate, recognizable construction, but something else, something more subtle, more ancient, and perhaps more alien, something that exists in the vast, gray, theoretical area between a natural, inert object and purposeful, active technology. Avi Loeb has used the carefully chosen phrase, post-biological artifact. What does that mean? Think about how our own civilization sends probes into the vastness of space. Voyager, New Horizons. These are machines, robots, designed to survive for decades, even centuries, traveling through environments of hard vacuum and intense radiation where fragile organic life could not possibly exist. There is no crew. There is no life support. There is just instrumentation and programming, patiently carrying out their pre-planned objectives long after their creators have moved on to other things, or perhaps have ceased to exist altogether. Now, imagine that same fundamental approach scaled up across geological, even astronomical, timescales. An object launched not decades ago, but millions or even billions of years ago. A probe not designed to report back to a home world, but to drift silently and patiently through interstellar space, gathering data, analyzing systems, and perhaps, most critically, possessing the ability to fabricate tools, to build infrastructure, to replicate itself when it encounters an interesting or resource-rich star system. This is the concept of a von Neumann probe, a well-established theoretical construct in the scientific search for extraterrestrial intelligence. If a sufficiently advanced civilization wanted to explore the entire galaxy without the impossible biological and temporal costs of sending living beings on generation ships, self-replicating probes would be the most logical, efficient, and inevitable solution. You launch a handful of them. They travel for millennia. They reach new star systems. They use the local resources, the asteroids, the dust, the planetary materials, to build copies of themselves. Those new copies then launch themselves toward new, unexplored systems. The process repeats exponentially. Within a few million years, a mere blink of an eye in geological time, a single civilization could seed the entire galaxy with its technological presence. And if such probes exist, if they are out there, silently plying the darkness between the stars, what would we expect to see if one of them happened to enter our solar system? We would expect to see an object on an unusual, highly improbable trajectory, perhaps one that is aligned with the ecliptic plane to facilitate easier travel between the planets. We would expect it to have anomalous chemical signatures, not because it is trying to hide something, but because it is constructed from materials that have been optimized for extreme durability and longevity, rather than materials that have been formed through natural, chaotic geological processes. We would expect it to have an unusually high mass and density, making it more resilient to radiation damage and harder to deflect from its course. We would expect it to exhibit strange behavior, perhaps appearing to be outgassing like a comet, but without demonstrating the typical non-gravitational acceleration, suggesting that the coma might be a deliberate, functional process, a form of braking or heat management, or even a cloud of nanomachines, rather than the passive, uncontrolled sublimation of surface ice. And most troublingly, we might expect such an object to become particularly active not near our own planet, Earth, but near our neighbor, Mars. From the perspective of an alien probe, Earth is a complex and potentially dangerous environment. It is noisy, technologically active, and biologically chaotic. But Mars is the perfect workshop. It is a world with a thin atmosphere, reducing the challenges of landing and construction. It is rich in critical resources, with confirmed water ice at its poles and a wealth of useful minerals in its soil. It has all the raw materials needed for large-scale construction. If you were designing an automated probe with the objective of establishing a long-term operational and manufacturing foothold in a new star system, where would you start? You wouldn't start on the noisy, inhabited planet. You would start on the quiet, resource-rich, and conveniently located planet right next door. This is speculation. I want to be absolutely clear about that. There is, as of this moment, no definitive, irrefutable proof that 3I/Atlas is anything other than a natural, albeit extremely unusual, comet. The strange chemistry, while deeply puzzling, is not yet proven to be impossible through some unknown natural process. The highly improbable trajectory, while statistically shocking, is not strictly forbidden by the laws of physics. The immense mass, while surprising, could simply reflect a set of formation conditions in its home star system that are wildly different from our own. Every single anomaly, on its own, has a potential, however strained, natural explanation. But when you are forced to stack those tenuous explanations one on top of the other, when you have to account for the sheer, compounding number of coincidences and statistical improbabilities required for the natural interpretation to hold true, it begins to feel less like parsimony and more like a desperate, collective act of willful ignorance. This brings us to the central, unspoken question that hangs over this entire affair. What is being built on Mars? Between October 4th and October 20th, during and immediately after the flyby of 3I/Atlas, independent satellite image analysts, the digital archaeologists of our time, flagged a series of new, subtle surface disturbances in several regions of the Martian surface. Some of these were in the very same regions where other unexplained, geometric-looking features had been noted in archived images from previous years. These are not massive, obvious structures. They are not pyramids or cities. They are subtle, almost imperceptible changes, faint linear features in the dust, new and unusual patterns in the soil on the floors of ancient craters, disturbances that seem to defy easy geological explanation. Now, correlation is not causation. This is a mantra of science for a good reason. Mars is a geologically active planet in ways we are still only beginning to discover. Seasonal frost patterns, the sublimation of subsurface ice, and the constant, slow-moving accumulation of dust can all create surface features that might appear artificial or strange to our pattern-seeking human eyes. But the timing of these new disturbances, appearing within days of the closest approach of 3I/Atlas, is impossible to ignore. Is it just another coincidence in a long chain of coincidences? Or are we watching, through the remote eyes of our robotic probes, the early, quiet stages of something we do not have the context or the courage to understand? If a von Neumann probe were to begin establishing manufacturing capabilities in a new star system, Mars would be the logical, strategic choice. It is close enough to Earth to allow for detailed observation, but far enough away and quiet enough to allow for its work to proceed undisturbed and undetected. Whatever 3I/Atlas is, whatever its true nature, and whatever it does in the coming weeks and months, the conversation and the controversy surrounding it have already revealed a profound and uncomfortable truth about our own civilization. We are not ready. We are not ready technologically. We possess no capability to intercept or even closely approach an object moving at this incredible speed. We are not ready institutionally. Our global space agencies have demonstrated a shocking inability to coordinate and communicate, and crucial data has been withheld from the public at the most critical moments. And perhaps most importantly, we are not ready socially or philosophically. The mere suggestion of an artificial origin for an anomalous object is still met, even in the face of overwhelming evidence, with institutional suppression, academic ridicule, and public denial. We seem to be fundamentally afraid to ask the most important questions, perhaps because we are terrified of the potential answers. 33 billion tons. No threat, they say, but perhaps the threat was never about a physical impact. Perhaps the real threat is to our collective worldview, to our comfortable and long-held assumption that we are the sole proprietors of intelligence in this vast cosmos. Perhaps the threat is the imminent, unavoidable end of our cosmic childhood, the moment we finally, truly realize that we are not alone. And the terrifying possibility that follows is that we are utterly, woefully unprepared for what comes next. If you have watched this far, if you have followed this chain of evidence and speculation, you understand the profound gravity of these questions. This story is not over. It is unfolding in real time, day by day. The data is still coming in, and the implications, whatever they may ultimately be, will echo for generations to come. Understanding this story, engaging with these possibilities, is not just a matter of idle scientific curiosity. It is about confronting our true place in the universe. If you believe this knowledge is important, if you believe this conversation needs to happen, please like this video so that the algorithm shows it to more people, so that more minds can join this critical discussion. The silence that followed was a character in itself, a living, breathing entity that settled over the planet. For 2 long, agonizing weeks, from the final days of October into the first uncertain days of November 2025, 3I/Atlas was gone. It had slipped behind the incandescent fury of the sun, lost to us, hidden from every telescope and every watchful eye on Earth. The world, which had become accustomed to a constant stream of nightly updates, frantic debates, and ever-deepening analysis, was plunged into a state of suspended animation. We were flying blind into the most significant astronomical event in history. This vacuum of information, this sudden, deafening quiet, did not bring calm. It did the opposite. It became a fertile ground where speculation, anxiety, and fear could fester and grow, unconstrained by the inconvenient friction of facts. The global media, having exhausted every credible astronomer and astrophysicist, turned its attention elsewhere. In a desperate bid to fill the 24-hour news cycle, they platformed prophets, philosophers, and mystics. Centuries old, cryptic quatrains from Nostradamus were unearthed, translated, and reinterpreted with a terrifying new relevance, with self-proclaimed experts insisting that his vague verses clearly foretold the arrival of a celestial messenger, a harbinger of either salvation or doom. Mainstream news channels, which weeks earlier had treated the story as a scientific curiosity, now ran primetime specials with dramatic, ominous titles like Contact and The Visitor. Their graphics departments worked overtime, creating slick, terrifyingly realistic renderings of the object based on the flimsiest of data and the wildest of speculations, each one more menacing than the last. The fuzzy, indistinct that had been transformed in the public imagination into a sleek, metallic predator. On the internet, the absence of new facts only accelerated the creation of new, more elaborate fictions. The narrative of a coordinated, global cover-up ceased to be a fringe theory and became the default, logical assumption for millions. Every down server, every mysteriously deleted social media post was no longer seen as a simple technical glitch, but as a clear and deliberate act of state-sponsored suppression. The United States government shutdown, which had so conveniently and abruptly ended just as 3i/Atlas disappeared behind the sun, was now recontextualized. It was no longer viewed as a moment of embarrassing political dysfunction, but as a brilliantly executed strategic smokescreen, a calculated maneuver to buy time, to allow the world's authorities to regroup, control the flow of information, and prepare a unified, sanitized narrative before the object re-emerged into view. The silence from official channels was absolute, a perfectly maintained, impenetrable wall of non-commentary. NASA's press office, back at full operational strength, issued a steady stream of bland, routine statements about Martian weather patterns, the status of the Perseverance rover, and the launch schedules of upcoming commercial satellites. It was a surreal, almost theatrical performance of bureaucratic normalcy in the face of the most abnormal and potentially transformative event in human history. Meanwhile, in the quiet, remote, and often forgotten corners of the world, a different, more patient kind of watch was being kept. The Galileo Project, Avi Loeb's small, independent, and often controversial coalition of scientists, continued their work. Their mission was not to study known phenomena, but to systematically search for technological signatures, for artifacts of non-human intelligence. They scanned the night skies with their bespoke network of observatories. They weren't looking for 3i/Atlas itself. They knew it was hidden. They were looking for its hypothetical children. If Loeb's most unsettling and radical theory was correct, if the object had indeed used its passage behind the sun as a cloak to release smaller, secondary probes, these objects would now be on silent, unpowered intercept courses with Earth. The project's highly sensitive instruments, designed to detect the faint glints of sunlight off non-natural surfaces and to track anomalous, high-speed movements, worked tirelessly through the nights. But the sky is vast, and their resources were painfully finite. It was an almost impossible task, like trying to spot a single, specific school of minnows in the entirety of the Pacific Ocean from the deck of a single, small fishing boat. Each night, their automated systems sifted through terabytes of data, and each night, they found nothing. And each morning, The world awoke with a renewed, fragile sense of anxious relief. A temporary reprieve that would last only until the next sunset brought the watching and the waiting back again. Then, in the second week of November, it returned. A faint, almost imperceptible pinprick of light, clawing its way out of the dawn's solar glare, spotted first by the Pan-STARRS Observatory on the summit of Haleakala in Hawaii. A brief, coded message flashed across the astronomical alert networks. It was back. Across the planet, a silent, coordinated ballet of machinery began. Telescope domes ground open, massive mirrors swiveled in unison, a silent, planetary gesture of intense, unified focus. The first low-resolution images confirmed the most basic and crucial fact. It was still there. It had survived. The intense, unimaginable heat and gravitational stress of its close solar passage had not torn it apart, had not caused it to disintegrate into a cloud of dust and gas. The relief that swept through the global scientific community was palpable, a collective exhalation of breath. But it was a relief that was destined to be incredibly short-lived. Because as the first high-quality, detailed images began to come in from the major observatories, it was immediately, shockingly clear that something had changed. Something profound had happened while it was hidden from our view. The object was now brighter, significantly more active than it had been before its solar encounter. And it was sporting a new, dramatic, and utterly bizarre feature. A colossal, well-defined jet of gas and dust erupting from its nucleus. Astronomers had, of course, expected an increase in activity. The closer a comet gets to the sun, the more it outgasses. But the structure and orientation of this new jet were deeply strange. Instead of trailing away from the sun, pushed back by the constant pressure of the solar wind and solar radiation, the way every normal comet tail behaves, this new jet appeared to be shooting forward, almost directly towards the sun. Mainstream cometary scientists and astronomers quickly flooded the preprint servers and news sites with explanations. It was likely, they argued, a phenomenon known as an anti-tail. This is a known, if somewhat rare, cometary feature where large, heavy dust particles, which are less affected by solar radiation, are left behind in the comet's own orbit. Due to the specific viewing geometry from Earth, these particles can create the optical illusion of a tail that appears to point towards the sun. It was a trick of perspective, a simple matter of geometry, they insisted. But to a global public that had been primed for weeks to expect strangeness, the image was deeply and powerfully counterintuitive. It did not look like an illusion. It looked like an act of defiance. It looked, for all the world, like an engine firing, a plume of exhaust pushing against the immense, overwhelming force of the sun. The spectacular image, captured in stunning detail by the European Southern Observatory's very large telescope, went viral almost instantly, spreading across every social media platform on the planet, almost always captioned with the same simple, recurring, and deeply unsettling question: what is it pushing against? The visual drama of the sunward jet, however, was ultimately a sideshow. The real, definitive moment of truth, the answer that the entire scientific world was holding its breath for, would come not from a picture, but from the cold, hard numbers of its trajectory. For days, astrometricians, the celestial map makers of the astronomical world, worked around the clock. They collected thousands of new positional data points from observatories around the globe, feeding them into supercomputers, refining their complex orbital models, all in an effort to answer the single most important question that humanity had ever faced. Had it maneuvered? This was the ultimate test. This was the moment that would either validate or completely demolish Avi Loeb's most radical and controversial hypothesis. If the object was merely a passive, natural comet, its new, post-perihelion path would be perfectly predictable. It would be governed by the clean, elegant laws of gravity, with a small, random deviation caused by the chaotic, unpredictable push of its outgassing jets. But if it was artificial, If it had deliberately and intelligently used the solar flyby for a gravitational assist or a targeted course correction, the deviation from that natural path would be there, a clear, unambiguous signal encoded in the data. The results, when they were finally compiled, cross-verified, and released, were the worst possible outcome for anyone hoping for clarity. They were profoundly, maddeningly, terrifyingly ambiguous. The object's new orbit was not a perfect match for the purely natural gravity plus random outgassing model, but the deviation was tiny, statistically borderline. Over a journey of millions of kilometers since its perihelion, it had departed from its predicted natural path by only a few hundred kilometers. The scientific community, already fractured, shattered completely. One camp, the scientific establishment, the mainstream, declared victory. The deviation, they announced in a series of coordinated press releases, was well within the expected margin of error. The object's unexpected brightness and its massive new jet, they argued, were clear evidence of powerful, asymmetrical outgassing, a natural rocket effect that perfectly and completely accounted for the minute, almost imperceptible course change. The case, they declared, was closed. It was a natural, albeit a very, very strange, comet. But Avi Loeb and his small, beleaguered circle of allies and colleagues saw something entirely different in the same data. They argued that the object's immense, unprecedented mass, the 33 billion tons that made it so incredibly difficult to push, meant that even this tiny, few hundred-kilometer deviation required an enormous, sustained, and precisely targeted force. Random, chaotic outgassing, they calculated, would be like trying to steer a battleship with a handheld fire extinguisher. The observed deviation, however small it appeared, was consistent with a deliberate, highly efficient, low-energy course correction. It was, they claimed, proof of intelligent navigation, subtle and masterful. The debate raged, not in public press conferences, which were now carefully controlled, but in the esoteric world of scientific preprint servers, in password-protected university forums, and in encrypted email chains between trusted colleagues. It was a war fought not with words, but with statistics and error bars and complex modeling assumptions. It was a battle for the very soul of astronomy, for the future of how we interpret our place in the cosmos. The world wanted, it desperately needed, a simple yes or no. But science, in its frustrating, rigorous honesty, had given it a maybe. And in the vast, uncertain space of that maybe, all the fear, all the anxiety, and all the wildest speculation found fertile ground to grow and metastasize. Just as the scientific argument reached a seemingly permanent stalemate, a new hope for definitive data emerged, and it came from an unexpected quarter, our own robotic emissaries in deep space. It turned out that two of our most advanced deep space probes, sent on missions to the outer solar system years earlier, were on trajectories that would give them a unique, close-up perspective on the visitor. The first was the European Space Agency's Jupiter Icy Moons Explorer, or JUICE. This sophisticated probe, on its long, looping journey to study the moons of Jupiter, was on a flight path that, by a stroke of cosmic luck, would carry it within 64 million kilometers of 3I/Atlas in early December 2025. It was a challenging, long-range observation, but the ESA confirmed that they would attempt to use the spacecraft's powerful cameras, its sensitive spectrometers, and even its plasma and particle sensors to study the object as it flew past. This was a tantalizing prospect. It was a chance for an up-close chemical and physical analysis, far from the distorting, light-polluting effects of Earth's atmosphere. It was a chance to get a clean, unadulterated signal. But there was a catch, a detail that felt like a deliberately cruel plot point in a cosmic thriller. Due to the extreme thermal constraints on the spacecraft during its journey through the inner solar system, the massive volume of data from the JUICE observations was not expected to be fully downlinked and processed back on Earth before February of 2026. We would have to wait. The answer was out there, floating in the memory banks of a robot millions of miles away, but it was months away from our grasp. Then came the second, even more dramatic, and potentially more revealing opportunity. NASA's Europa Clipper spacecraft, on its own multi-billion-dollar mission to search for life in the subsurface oceans of Jupiter's moon Europa, was predicted to pass directly through the extended ion tail of 3I/Atlas between October 30th and November 6th. The timing was staggering. Clipper wouldn't be able to see the object's nucleus, but it would do something arguably more important. It would taste it. Its highly sensitive instruments, particularly the Plasma Instrument for Magnetic Sounding, PMS, and the Surface Dust Analyzer, SUDA, designed to sample the faint plumes of water erupting from Europa, could directly analyze the charged particles and dust grains streaming away from the interstellar visitor. This was an unprecedented, once-in-a-lifetime chance to study the raw, primordial material of an object from another star system, to hold it, chemically, in our hands. Would it find the expected composition of a water ice and silicate comet? Or would it detect the anomalous, impossible nickel-to-iron ratio? Or would it detect something else entirely? Something unexpected? Something that would betray an artificial, manufactured origin? As if that weren't enough, it was soon discovered that a third spacecraft, the ESA's Hera mission, on its way to study the Didymos asteroid system, would also have a glancing encounter with the tail. Suddenly, we had multiple, independent chances to get ground truth data. But again, the data downlink and analysis process was slow and painstaking. The universe was offering up its most profound secrets, but only on its own, agonizingly slow and deliberate schedule. As the scientific community and the watching world settled in for the long, tense wait for the data from deep space, the simmering conspiracy narrative took a dark, ugly, and deeply personal turn. In mid-November, a new, explosive leak appeared. This time, it wasn't a cryptic, anonymous post on a fringe forum like 4chan. It was dropped on a secure, encrypted messaging service, and it was quickly authenticated by cybersecurity experts as originating from within the ESA's internal network. This time, it wasn't a trove of technical data or spectral charts. It was a collection of internal communications. It was a long, damning chain of emails, purportedly between senior officials at NASA's Jet Propulsion Laboratory and their direct counterparts at the European Space Agency's Operations Center in Germany. The authenticity of the emails was, and remains, a subject of fierce debate, but the language, the tone, the sheer bureaucratic anxiety they contained was chillingly plausible. The emails, all dated from the critical period of the Mars flyby in early October, showed none of the calm, professional certainty that had been projected in the official press releases. Instead, they revealed a state of profound confusion, deep division, and growing alarm among the very people in charge of the missions. One message, allegedly from a high-ranking NASA project scientist for the Mars Reconnaissance Orbiter, was particularly shocking. It read, "We cannot reconcile the latest high-rise albedo data with any known natural object. The variations in reflectivity are not random. We are seeing repeating, non-random geometric patterns at the pixel level. We are holding the data as per the DC Security Directive. The official public reason for the delay remains the shutdown backlog." Another email, from a senior manager at the ESA, discussed the agency's intentionally blurry ExoMars images. The message was blunt. The public is calling us incompetent, which, at this stage, is a far better outcome than the alternative. Let them think our cameras are poor. We absolutely cannot release the full, unredacted spectral analysis from the TGO instrument. The nickel signature is only part of the problem. What is our unified position on what to do about the anomalous isotopic ratios? Isotopic ratios. The leak didn't explain what that meant, which made it all the more terrifying. It was a detail so specific, so technical, so esoteric, that it felt undeniably real. It suggested that the already bizarre nickel without iron problem was just the tip of a much larger, stranger, and more inexplicable chemical iceberg. The leak, if genuine, painted a picture not of a sinister, monolithic global conspiracy to hide aliens, but of something far more believable and far more frightening. A group of dedicated, brilliant scientists and administrators caught in an impossible, unprecedented situation, trapped between their scientific duty to publish data and a strict, top-down directive from national security channels to withhold data that they themselves did not fully understand and which they feared could cause irreversible global panic and social collapse. This new leak, far more than the technical data or the trajectory anomalies, acted as a catalyst, pouring gasoline on the already raging fire of public anxiety. The term black swan event, a concept from risk analysis describing a rare, unpredictable event with massive, world-changing consequences, began to trend globally on social media. Pundits, politicians, and online influencers seized upon the term, framing the arrival of 3I/Atlas as the ultimate black swan, a genuine, capital U unknown that our fragile, interconnected global civilization was structurally and psychologically incapable of handling. The societal fabric, already strained by years of political polarization, economic instability, and environmental crises, began to fray visibly at the edges. Doomsday cults and apocalyptic religious movements, some old and obscure, some newly formed around the mythology of the object itself, saw their membership swell exponentially. Their charismatic leaders, broadcasting to millions on social media, preached that 3I/Atlas was a divine judge, a planetary purifier sent to cleanse the Earth, or a cosmic ark, a technological savior sent to carry the faithful away to a new paradise among the stars. The reinterpreted Nostradamus prophecies went from a fringe internet curiosity to a mainstream cultural phenomenon, with cheaply printed books on the subject topping international bestseller lists. The world, faced with a mystery that science could not, or would not, explain, was desperately searching for a framework, any framework, to make sense of the incomprehensible. Governments, which had until now maintained a posture of detached observation, were finally, and visibly, beginning to act. But their actions, intended to reassure the public, only served to deepen the suspicion and paranoia. The International Asteroid Warning Network, or IAWN, a global body coordinated by NASA and the United Nations, announced the launch of a special, high-priority comet campaign to observe 3I/Atlas continuously from late November 2025 through January of 2026. The stated, public goal of the campaign was to refine observational methods for pinpointing the comet's exact position and to test international communication protocols. On the surface, it was a perfectly reasonable, even laudable, scientific initiative. But independent journalists and researchers digging into the history and charter of the IAWN quickly noted that this was the very first time that an interstellar object, an object officially declared to pose no threat, had ever been the target of what was, for all intents and purposes, a planetary defense-level monitoring drive. The question was obvious and was asked with increasing volume. If the object poses no threat, why are you mobilizing a planetary defense network? Was this, as the officials claimed, simply a convenient and timely opportunity to test their systems and run a drill? Or was it a quiet, unacknowledged admission that, behind the carefully constructed curtain of public relations, they were taking the potential threat far more seriously than they were letting on? The IAWN campaign felt less like a scientific study and more like a global military watch, a planet turning its collective, fearful gaze on the intruder in its midst, waiting and watching for it to make its next move. With the world's attention now firmly, obsessively fixed on the post-perihelion trajectory and behavior of 3I/Atlas, the strange, subtle, and inconclusive events that had been observed on the surface of Mars were almost entirely forgotten. Almost. In the quiet, niche forums where a small, dedicated community of digital archaeologists spent their days and nights poring over the terabytes of archived data from the Mars Reconnaissance Orbiter. A new, startling discovery was made. An independent analyst based in Germany, comparing thermal imaging data from the orbiter's CRISM instrument, the compact reconnaissance imaging spectrometer for Mars, taken before and after the October flyby, noticed a faint, transient, and highly localized heat signature. It was located in one of the flat, unremarkable, and geologically boring plains where other analysts had previously noted the appearance of subtle, new, and unexplained linear surface disturbances. The heat signature was incredibly weak, just a few degrees warmer than the surrounding frozen terrain, and it lasted for only a few hours in the deep, pre-dawn cold of the Martian morning before fading away completely. It was a single, ambiguous data point, an observation that, taken by itself, meant almost nothing. It could have been a sensor artifact, a patch of unusually dark soil absorbing a bit more heat from the distant sun, or any one of a dozen known, natural geological or atmospheric phenomena. But in the context of everything else, the anomalous trajectory, the impossible chemistry, the missing high-resolution images, the government shutdown, the deeply unsettling leaked emails, it was yet another piece of the puzzle that simply did not fit. A faint, unexplained warmth, emanating from a patch of ground that had been visibly disturbed at the exact time a 33 billion-ton object of unknown origin and potentially intelligent design was making its closest pass. The question that had been whispered before, the question that had been relegated to the fringes, was now being asked with a new, terrifying urgency in the highest corridors of power. What is being built on Mars? Is it a base? A factory? A resource extraction site? A relay station? We were staring, from a distance of 100 million miles, at a potential construction site, with no way to know who the builders were, what their capabilities were, or, most importantly, what they intended. We were like the natives of a previously uncontacted tribe, standing on a shore, watching a strange, impossibly large ship anchor in our bay, seeing small boats row towards a deserted island just offshore, and hearing the faint, rhythmic, and deeply unnerving sound of hammers on steel, a sound carried to us on the wind, a sound unlike any we had ever heard before. The weeks that followed were a study in cognitive dissonance. On one hand, the machinery of normal life churned on. People went to work, markets fluctuated for mundane reasons, and the relentless churn of the 24-hour news cycle, having exhausted the shock value of 3i/Atlas, moved on to more terrestrial scandals and political squabbles. The object, still receding into the darkness of the outer solar system, began to fade not just from our telescopes, but from our collective consciousness. It was too distant, too abstract, too profoundly strange to occupy our attention for long. The official narrative, carefully crafted and relentlessly reinforced by government agencies and mainstream science communicators, had taken root. 3i/Atlas was a hyperactive comet, an unusual but ultimately natural phenomenon. The anomalies, they explained, were the result of its pristine, volatile surface reacting to its very first encounter with the star, causing it to outgas in unpredictable and powerful ways. The trajectory deviation was a result of this outgassing. The chemical signature was a reflection of its unique, but not impossible, formation environment. The story was neat, tidy, and, most importantly, reassuring. But beneath this placid surface of enforced normalcy, a different reality was taking shape. The subculture that had grown around the object, the trackers, the anomalists, the citizen scientists, did not move on. For them, the official explanation was not an answer. It was an insult to their intelligence. It was a flimsy, paper-thin story designed to calm the public, a scientific lullaby to put a frightened populace back to sleep. They continued their work with a quiet, almost religious fervor. They sifted through the mountains of public data, rerunning calculations, developing new image enhancement algorithms, and collaborating across a global, decentralized network of encrypted chats and private forums. They were searching for the signal in the noise, the one piece of irrefutable evidence that would tear the official narrative to shreds. Their focus shifted from the object itself to the lingering questions it had left in its wake. The primary obsession became the missing high-rise images from the Mars flyby. The shutdown backlog excuse had long since worn thin. A grassroots campaign, organized entirely online, began to bombard NASA with Freedom of Information Act (FOIA) requests, demanding the release of all data from the Mars Reconnaissance Orbiter for the period of October 3rd to October 5th, 2025. The requests were stonewalled. NASA's official responses were masterpieces of bureaucratic obfuscation, citing national security exemptions, proprietary data protocols, and the ongoing analysis process. Each refusal, however legally worded, only served as further proof to the community that something was being hidden. The high-rise images became the Holy Grail, the Zapruder film of the 3I/Atlas event, a piece of evidence so powerful that a global conspiracy had been enacted to keep it from public view. Then, in late December 2025, a stunning breakthrough occurred. A small, independent team of data scientists and astrophysicists, funded by a private consortium of wealthy tech entrepreneurs sympathetic to the Galileo project, announced that they had developed a new technique to analyze the faint, scattered light from a comet's coma. Their method, which they called coma photometric tomography, used complex algorithms to reconstruct the shape and density of the nucleus based on the subtle patterns of how sunlight reflects off the surrounding gas and dust. It was a way to see the nucleus without actually seeing it directly. They applied their technique to the vast public archives of ground-based telescope images of 3I/Atlas. The results, published on a preprint server in the first week of January 2026, were electrifying. The reconstructed shape was not the irregular, potato-like form of a typical comet nucleus. It was a highly symmetrical, complex, and geometric structure. The paper described it as a trifaceted polyhedron with significant surface articulation. In layman's terms, it was a pyramid or something very much like one. The paper was cautious, filled with caveats about the experimental nature of their technique and the potential for modeling errors. But the accompanying images, the stark, computer-generated models of the object's core, were unambiguous. They showed a shape that could not, by any reasonable definition, be natural. The scientific establishment reacted with swift and brutal hostility. The paper was denounced as pseudoscience, irresponsible speculation, and an abuse of statistical modeling. The authors were accused of cherry-picking data and using flawed algorithms to generate a sensationalist result. They were ostracized, their careers threatened. But it was too late. The images were out. The pyramid in the heart of the comet became a global icon of the cover-up, a symbol of the truth that was being suppressed. For the millions who had always believed that 3I/Atlas was more than just a comet, this was the vindication they had been waiting for. The war for the narrative was over, and the official story had lost. As the public debate over the object's true nature reached a fever pitch, the focus of the world's intelligence agencies and military commands shifted to the second, more terrifying part of the equation, Mars. The faint thermal anomalies and subtle surface disturbances were no longer just curiosities for amateur analysts. They were now viewed as potential evidence of an active, off-world industrial presence. A new, undeclared space race began. In a series of rapid, almost panicked announcements throughout early 2026, the United States, China, Russia, and a new European consortium all declared their intentions to launch a new wave of missions to Mars, all scheduled for the next launch window. The official justifications were scientific: the search for life, the study of Martian geology, the preparation for future human settlement. But to any informed observer, the truth was obvious. These were reconnaissance missions. They were sending probes armed with the highest resolution cameras and the most sensitive instruments available, their primary, unspoken objective to get a clear, undeniable look at what was happening on the ground in those anomalous regions. The world was now in a state of high-stakes, planetary-scale suspense. We were waiting for two things. We were waiting for the data from the JUICE and Europa Clipper flybys, the ground truth, that would tell us the object's true chemical composition. And we were waiting for the first images from the new flotilla of Mars-bound spacecraft. Which answer would arrive first? The suspense was a palpable, global force, a low-grade, persistent anxiety that hummed beneath the surface of everyday life. The stock market became volatile, reacting to the slightest rumor or leaked document. New international treaties were hastily drafted, attempts to create a unified protocol for post-detection policy. But they were fraught with geopolitical tension and mutual suspicion. No one could agree on what to do, because no one could agree on what was happening. We were a species holding its breath. The first answer arrived in mid-February 2026. The European Space Agency held a press conference to announce the initial findings from the JUICE spacecraft's flyby. The atmosphere in the room, and in the world watching online, was electric. The project scientist, a veteran of dozens of missions, stood at the podium, his face grim. He announced that the spectral analysis of the object's coma was complete. And it was, he said, deeply anomalous. The nickel without iron signature was confirmed, and the isotopic ratios were, in his words, inconsistent with any known stellar nucleosynthesis model. But then came the bombshell. The instruments had detected a complex suite of heavy elements and rare earth metals, tungsten, gold, osmium, in quantities that simply should not be present in a comet. And they had detected complex, long-chain organic polymers that were not the simple prebiotic molecules found in other comets, but something more structured, more artificial. He paused, taking a long sip of water, the silence in the room absolute. "We cannot yet explain these findings," he said, his voice strained. "However, we can state with a high degree of confidence that the composition of 3I/Atlas is not consistent with that of a natural cometary body, as we understand them." It was the closest any official had come to saying the word artificial. It was a carefully worded, scientifically defensible statement, but its meaning was explosive. The dam had broken. The societal reaction was immediate and chaotic. For some, it was a moment of profound, spiritual awe, the confirmation of a deeply held belief that we were part of a larger, populated cosmos. For others, it was a moment of pure, existential terror. The stock markets plunged, triggering circuit breakers around the world. Governments declared states of emergency, not because of any direct threat, but to control the widespread civil unrest and panic buying that erupted in major cities. The world's religions struggled to respond, their ancient doctrines suddenly confronted with a reality they had never been designed to accommodate. The question, "Are we alone?" had been answered, and the answer was no. Amid this global chaos, a small, almost unnoticed announcement came from the Jet Propulsion Laboratory. The first of the new Mars reconnaissance probes, a fast-track NASA mission called the Mars Eye, had successfully entered orbit around the red planet. It was a month ahead of schedule, a testament to the urgency of its mission. Its primary camera, a next-generation instrument with a resolution that dwarfed even that of HiRISE, was being calibrated. The first images were expected within 48 hours. Those 48 hours were the longest in human history. The world waited. The chaos in the streets subsided, replaced by a tense, global vigil. Billions of people were glued to their screens, waiting for the first glimpse of the Martian surface, the first look at what had been built there, in secret, by our visitors. The images, when they finally came, were not released in a press conference. They were simply uploaded, without comment, to a public NASA server. And they showed nothing. They showed the flat, unremarkable plains, the crater floors, the regions of the faint thermal anomalies. And they were pristine, empty. There were no structures, no machines, No signs of any activity whatsoever. The linear features that had been noted before were now clearly resolved as natural wind streaks in the dust. The thermal anomalies were gone. Everything was exactly as it should have been. It was just the empty, beautiful, desolate landscape of Mars. For a moment, there was confusion. And then a slow, dawning, and infinitely more terrifying understanding began to spread. The trackers, the anomalists, the people who had spent months staring at the evidence, were the first to piece it together. The disturbances on Mars were real. The thermal signatures were real. The construction was real. But we had made a fundamental, tragically geocentric assumption. We had assumed that whatever was being built on Mars was being built to last. We had assumed it was a base, a permanent installation. It wasn't. It was a factory. A temporary, automated, self-replicating factory that had used the raw materials of the Martian soil to accomplish a task. And once that task was complete, it had done what it was programmed to do. It had erased itself. It had disassembled, leaving no trace, a perfect, sterile construction site. The only question that now mattered, was, what did it build? The answer to that question came 3 days later. It came not from a telescope or a space probe, but from NORAD, the North American Aerospace Defense Command. At 4:37 Greenwich Mean Time, their deep space radar network detected a cluster of new objects. They were small, no more than a few meters in diameter, and they were dark, coated in a material that absorbed over 99% of radar waves. And they were on a direct, high-speed trajectory for Earth. There were thousands of them. We had been so focused on the giant, 33 billion-ton object, so busy debating its nature and its intent, that we had missed the real threat. 3I/Atlas was never the weapon. It was the delivery system. It was the carrier, the mothership. The factory it built on Mars wasn't for colonization. It was an arsenal. It had built the bullets, and it had fired them. The story of humanity's encounter with 3I/Atlas ends here, not because there is no more to tell, but because what came next is a different story. It is a story of impact, of survival, of a world changed in ways we could never have imagined. But the story of the visitor, the story of the mystery, concludes with this terrible, final revelation. The official story was wrong. The conspiracy theories were wrong. Everyone was wrong. We were not dealing with a natural comet. We were not dealing with a peaceful explorer. We were dealing with something ancient, intelligent, and utterly implacable. Something that had judged us. The final, haunting question that we are left with, the question that will be debated by the survivors for generations to come, is the most terrible of all. Were the objects sent to Mars to build weapons a response to something we did? Was it the wow signal, our own innocent, naive shout into the darkness, that triggered this response 48 years later? Or was the plan always the same? Was this just routine pest control, a galactic gardener clearing a world of a potentially troublesome infestation before planting something new? We will likely never know. If you have watched this far, you are no longer just a spectator. You are a witness. You have followed the trail of evidence to its final, devastating conclusion. The request to like and subscribe seems so trivial now, so utterly meaningless in the face of what we have learned. But the purpose behind it remains. The sharing of knowledge, the act of bearing witness together, is the only thing we have left. The next video on your screen is not a speculation. It is the first chapter of what happened next. If you have the strength, watch it. Learn from it. And remember what it was like to look up at the stars and feel a sense of wonder before we learned to look up and feel a sense of dread. Remember what we were before we knew what we were dealing with.